So among the midterm practice problems, I listed this one, or this list of ionic compounds, and I asked which of them is not a valid ionic formula. Now, just because you can write a metal and a nonmetal, or a metal and an anionic ion like hydroxide together, doesn't mean that this formula is correct. The charges have to balance between the cations that are supposed to be listed on the left-hand side and the anions that are supposed to be listed at the end on the right-hand side of the molecular formula. Let's look at the first formula, aluminum chloride. And if you find aluminum in the periodic table, you'll find that it is 1, 2, 3 electrons more than neon. It's a metal, so one would think that it would actually lose 3 electrons to have the same electronic configuration as neon. This loss of 3 electrons, since each is negatively charged, would leave the aluminum anion with a +3 charge. When we find chlorine on the periodic table, it is a nonmetal. It's actually one of those halogens, this row that's right next to the noble gases. And chlorine has 1 less electron than argon, the next noble gas. So if it gained 1 electron, it would have a stable electronic configuration. It would have a -1 charge. So we would expect that a chloride ion would have a -1 charge. With this in mind, we have to ask the question, how many chlorides does it take to balance an aluminum ion? So the aluminum ion has a 3+ charge, the chloride anion has a 1- charge, and if you think about it, it would actually take 3 chlorides to balance the 3+ charge, since each one of those chlorides would have a -1 charge. So overall, if I was to take those 3 -1 charges and add them together, I get -3. That plus the +3 charge of aluminum would have an overall charge of 0. That means that this aluminum chloride formula, AlCl3, is correct. So A is correct. Next, we'll go to magnesium hydroxide. And the hydroxide ion has a -1 charge. You could either look that up, or you could use the charges of oxide and hydrogen to determine that it was a -1 charge. Magnesium is in the second column. It's 2 electrons more than neon, the prior noble gas. Since it's over here on the left-hand side of the periodic table, it's a metal. It's going to lose electrons. It's going to lose 2 electrons, 1, 2, to get the noble gas configuration of neon. So it's going to be a +2 charge because it lost 2 negatively charged electrons. Each hydroxide is a -1 charge. So it will take 2 hydroxides to balance the charge of 1 magnesium 2+ ion. So for that reason, the formula of MgOH2, that's actually correct. This is the right formula for magnesium hydroxide. So both A and B are correct. Next, let's look at sodium iodine, or sodium iodide. And the formula they gave us has 1 sodium and 2 iodides. So if you look at the periodic table, sodium is in this first column. It's a metal. It's going to lose 1 electron. It's going to become a cation, or a positively charged ion. It's going to lose 1 electron. So that means it's going to have a +1 charge. Next, if we look at iodine, it's a halogen. It's a nonmetal, so it's going to gain 1 electron. It's going to have a -1 charge as an ion. I don't have to actually write the 1. It's implied if you put a -1, or minus charge, that it's -1. So this is balanced. 1 sodium and 1 iodine is totally balanced. If I have 1 sodium and 2 iodines, that's a -1 charge overall. So this isn't charge balanced. The formula they gave us here is wrong. This is not charge neutral. It doesn't have a charge of 0. It has a charge of -1. This whole thing together, charge of -1. So C is clearly wrong. It's the wrong choice. If you work through D and E, you'll also find that these are correct. So both by identifying the wrong answer in C and also by using the process of elimination, you will find that C is the answer choice that is not the correct formula, which is what the question asks for in the first place.